Would you look at what we've got strung up in here? Oh, wow. Oh, Mark, what is all this?
Hey, girl. Hey, did you get the sun?
Yes, and the biggest one I could find was 1,000 watts.
Oh, that's all right.
Would you tell us what this is about?
Hey, just be careful. Don't bump into the planets, all right?
3, 2, 1. Contact is the secret, is the moment when everything happens. Contact is the answer, is the reason why everything happens. Contact. Let's make contact. 3, 2, 1. Contact.
Hey, which one's the moon?
Oh, it's the baseball. Over there by the blue soccer ball.
What is this, Sports Week?
Hey, Lise, would you help me out with Mars down there?
Which one? Oh, that's the kickball over there. Okay, do you want to hire?
Yeah, just pull it up a little bit.
Okay. Hey, remember, that's a 1,000-watt bulb. You sure you know what you're doing?
Be careful of Venus, would you?
Hey, which one's this, Mercury?
Yeah, this is Mercury and Venus. This is the Earth and the Moon. And this is Mars. The rest of the planets are out of the room.
Hey, do you want me to make a Saturn out of these?
Well, this isn't a scale model. And even if it was a scale model, Saturn would be too far away to fit in the room. All right, now all we got to do is turn on the sun.
You sure you got your wires right?
Don't worry. You and Mars over there are 140 million miles away. Okay, you ready?
Yep.
Here comes the sun.
The Count here, still seeking out darkness. Today you will learn how the sun shines upon the earth as a constant source of light and irritation. The next total eclipse of the sun here will be in 1991 in Hawaii. Don't miss it.
Maybe it's this one. You got it, at least. They're back on. You should have waited for Dr. Martinez to get here. From now on, Mark, no more outages. Yeah, and no more bright ideas.
They make light bulbs with machines inside factories. The insides first. That's the light stem, which is the center of the light bulb. Next comes the filament, which is the part that really lights up. It's only toward the end that they bring in the bulb.
Trini, Mark, I want you to meet Dr. Joe Martinez.
How do you do? How are you?
Hola, mucho gusto.
Encantado.
He knows all about the physics of light, so he can help you with your solar system.
Great, I could use some help. Well, tell me, what happened?
Well, I think this bulb was too big and it took up too much power, so we tripped a circuit breaker.
It looks like it's a pretty large light bulb.
Help him out.
Yes, I think we can. Here's a dimmer that I brought along.
Great.
And a new bulb.
I'll
Our
take
solar
it.
So
system
why
over
don't
here.
you...
Yeah, come on over
Want
here.
to put this in?
Yes, please do. Let's make sure that everything is unplugged before we do
Yes,
start.
okay.
Okay.
And
Gotta plug out.
we'll get going.
Yeah. Should I plug this?
Let's see. First of all, plug the dimmer into the wall outlet
Okay.
and make sure the switch is off.
It's on
And we'll
zero.
plug this in here, and we should be ready to roll. All we
Great.
have to do now is to gradually bring up the...
Just turn it up.
This is this dimmer is a device to bring up the intensity of the light bulb gradually so as not to burn it out.
Ah, so that'd help a lot. But is this bulb going to be large enough to play the role of the sun in my model here?
It should be adequate. It turns out that the sun is not the brightest and the largest star in our universe.
Mm-hmm.
It is just the star that is closest to us.
Oh, I see.
And those planets that are closer to the sun, of course, get the greater amount of sunshine compared to Mars, which is way out there, which gets very little amount of light, and as a result is pretty cold.
I get it. So those are all very cold, the ones further away.
Yes, the ones that are quite a distance away from the sun are quite cold, and those that are the nearest, like Mercury, they're pretty hot.
What about the Earth?
It turns out that the Earth itself gets just about the right amount of sunshine to sustain life.
I said it gets the perfect amount.
What?
Are you asleep?
Mm-hmm. Yeah.
Isn't it nice to be so warm, Ralph?
Yeah, I'm sweating.
We're a lucky couple of people, Ralph.
Oh, boy.
Just look where our ancestors used to live.
Now, I had a uncle once lived in Passaic.
I mean, our old ancestors.
Oh.
Look at this. They had nothing to heat them but the sun. Hey, I'm cold.
Do like me. Flap your arms.
Are you trying to keep warm?
No, I'm trying to fly to Miami for the winter. What ain't...
Oh, I'll be glad when you discover fire so we can heat ourselves with something besides that big ball up there. And great-grandmother dejectedly didn't have it much easier. Look.
Okay.
Well, we've finally got fire. It's such a secure feeling to know we don't have to depend on the sun for warmth anymore.
Where do you think this wood comes from? Wood City? It comes from trees. Trees can't grow without sun. No sun, no trees, no wood, no fire, no fire.
Out in the cold again. You know, burning this coal is a lot better than the wood.
Yeah, but I'm not sure we shouldn't put an oil burner in, like Darby and Joan next door.
Oh, I don't care. After all, none of us has to depend on that dumb sun for warmth anymore.
Coal and oil come from decayed plants and animals, my lovely.
So,
Without the sun, we
we got no plants.
No
plants, no coal, no oil, no
heat.
Yes, sir, Ralph. Our ancestors had it rough having to depend on the sun for warmth.
Uh-huh, they sure did.
I'm sure glad we outsmarted the old sun.
What's on the roof, Adele? Our solar heat panels. They heat our house and our water. Outsmarted, yeah.
Why don't you come sit down, Dr. Martinez?
Great, thank you. And please call me Joe, okay?
Okay.
Oh, fine.
Suppose it really happened.
Yeah, it did in my solar system.
No, I mean, suppose the sun actually went out.
You mean like...
Yeah, like a light goes out, right? So you figure you get a new bulb, a new plug, and some batteries. But remember, we only have one big local supplier up there, open daily dawn to dusk.
That's true, and once it goes out, we'll not have another one. But the first thing will happen is that things will be very cold all throughout the solar system. The Earth will cease to exist as the way we know it, life on Earth.
I mean, we just...
Yes, it'll get very
Stop.
cold and things will stop and
Is
die
it
out.
that cold?
It would get eventually that cold. However, don't worry about it. As near as we can predict, it'll be 10 to 15 billion years before it will go out.
So it's pretty important to keep a close watch on the sun, isn't it, Joe?
Yes, it's the best laboratory for me to do my work in studying the sun. We have no means of reproducing that kind of system on Earth. So what we do is pay attention to studies that are very important for terrestrial uses that occur in the sun.
Uh-huh. So do we know why the sun shines?
Yes, we do. It is a continuous hydrogen bomb, and as a result, it creates an awful lot of energy. And we are interested in controlling that reaction that causes a hydrogen bomb, so we will be able to produce energy on Earth. We expect that by the year 2000, we will have a pretty good idea of how to control, and indeed will be able to control this reaction. We study the sun using very special devices. We use satellites, we use special mirrors, and we use telescopes.
I've seen those at Kitt Peak.
Kitt Peak National Observatory, 7,000 feet above sea level. It's located in the Quinlan Mountains near Tucson, Arizona. There are lots of ways to look at the planets and the distant stars. Our star, the sun, is too bright to look at directly. At Kitt Peak, the world's largest solar telescope produces a reflected image of the sun. I talked to astronomer Bruce Gillespie about how this telescope works.
Why was the observatory built up on a mountain?
The higher you go, the less air there is above you to disturb the observations.
Are we inside the telescope?
Yeah, we're inside the telescope right now. We're at ground level right here. There's 200 feet of telescope above us, and 300 feet of it has been dug out right from the rocks in the mountain. At the very top of the telescope is a large flat mirror.
Will we be able to see how this experiment is working?
I think so.
When you look at an image of the sun, you see darker places called sunspots. Astronomers study them to find out how they affect the Earth.
Bruce, how long have people been studying sunspots in the sun?
Trini, they were first observed by Galileo. It was 1600s. He was one of the first people to use a telescope, and he saw these black things on the sun, darker things. And he reported it to people around the time, and they thought he was crazy.
What did they tell us about the Earth? Do they tell us anything?
Every 22 years, there'll be a year where there's very little water. And it turns out that the sunspots come and go with about a 22-year period.
So then the sunspots may be affecting our weather and in turn affecting
How life
our
is
food.
on Earth, that's right.
How large are the sunspots?
Oh, well, this one, which is about a ½ inch across on the image, is probably bigger than the Earth.
How much bigger?
Maybe 3-4 times bigger than the Earth.
Are they all that big?
Most of them are of that size class. Some of them are just monstrous, bigger than the planet Jupiter. But you could take the Earth and drop it right into that sunspot, and it would just swallow it right up. It wouldn't even blink. Most everything else is bigger than the Earth.
Why are there people living on Earth? Why aren't there people on the larger planets? Why here?
Well, it's a nice place to live. It's got the right temperature. It has water. It has oxygen in the air. One of the very important things, at least as far as animal life is concerned, is that the water doesn't freeze most of the time. Most of the other planets are either too hot that the water would be evaporated and boiling, or it'd be so cold that it'd be frozen, and there'd be no time that there would have liquid water.
What would happen if the whole sun went out?
Eventually, the Earth's atmosphere would freeze out. It would become, it would be snow. There would be snow all over the ground, which would be the air is turned into a solid or a liquid because of the lack of heat to keep it in a gaseous form.
That means we probably wouldn't be able to breathe because the oxygen would freeze.
That's right.
So if the sun dies, we die.
That's right.
So how much longer is the sun going to last?
Well, at least another 10 billion more years. Yeah, well, that's good. The sun's going to be around for a while, right? So, but for a while there, it was the only source of light we had.
Well, first of all, man has always wanted to have bigger and better sources of illumination. First, he controlled fire, he had torches, candles, and then lanterns. But then light is not only of value to us because it provides illumination. There are other new light sources that have a greater utility, such as a laser.
Oh, I've seen a laser once. It was red. It was a red laser.
Lasers are a very special form of light, and they have many, many uses other than illumination. For example, they are actually being used to replace telephone lines to carry voices over long distances.
Don't they also use them in supermarkets? They do?
Yes, the supermarket has a device that makes use of the laser because if you look at some of these boxes that you purchase, some of the goods, you'll find a series of parallel lines. Lines that are narrow and next to one another. And this pattern is passed over a glass window on the counter, and as a result of the laser light hitting this pattern and reflecting, it is translated by a computer to determine its price and determine how many pieces have been sold to keep an adequate inventory.
All that information on that little square with the lines?
That's true.
Here, Lisa, whenever we go into a laser lab, we always have to put on goggles.
Why?
It's for safety reasons, because the light from a laser is so intense that it could burn your eyes out.
No kidding, really? But put them on right now so we can know that?
Sure. Hi, Ralph. These are the samples that I brought by for you to test with your laser.
Where's the laser?
It's right here in this big, long box right in front of you.
Look at that, it's smoking.
Yes, you can see a laser beam is a very intense kind of beam. In other words, it has a lot of energy in it.
But where is the beam? I thought you would say like a beam of light.
Well, there actually is a beam of light, but it turns out in the laser, the light beam is so thin that you normally can't see it. And because this room is so clean, the only way you would see it is if we took and put a lot of dust and dirt in the room, because in that way, all the dust would scatter the light beam, and then you'd be able to see the beam. So if Ralph would like to take some dust and spray it in the room, then we'll be able to see the beam.
See it then?
This is a smoker, which will diffuse the red light, and you'll be able to see it.
There it is.
You see, now you can see how the beam is traveling as it comes out of the laser.
Now that looks more like the kind of laser that I'm used to seeing.
The beam comes from the laser, hits a beam splitter, and what a beam splitter is, it actually splits the beam. Right here we have what amounts to a flashlight. We'll just turn it on. Although the light looks white, it's really made up of all the colors of the rainbow. So there's red, green, and blue, and orange there. But if you look at our laser, there really is just one of the colors of the rainbow. So it's like taking this light and just picking out one of the colors, the red color. They have green lasers and yellow ones and pink ones and green ones. They even have lasers where the beam is really there, but you can never see it, and they call those infrared lasers.
Why can't you see it?
Well, it turns out that your eye is only sensitive to so many colors. And then there are other colors that are there, but your eye just can't see them.
Well, what do they use lasers for anyhow? I mean, like, what do they expect to be able to do with them in the future?
Well, this particular laser here we just use for research, but there are other kinds of lasers that people use for welding. Some people are doing art with lasers and sculpture, and they have lasers that they use in dentist's office and in medicine. So in every field that exists, there's practically somebody trying to find a way to use the laser.
Did they have lasers when you were growing up?
No, not by far. That was a long time before I...
How did you, because I thought they were fairly new. How did you get into it?
Well, it's a long story. Actually, I guess a better question would be, how is it that I got interested in science? And being raised in the West, I was around a country that is highly mountainous and also very clear so you can see the stars and the moon without too much difficulty.
Where are you from?
Arizona is where I was raised.
Is that where you were born?
Yes, I was born in Arizona. But it turns out that I used to sit, for example, in the back steps and watch the moon come out the horizon. And if you notice, the moon is much lighter there than it is when it's right above you.
Yeah.
So I wondered about this. I didn't know at the time that this could be explained by science, but this is what I was interested in. And also, if you look at the mountains and you see the clouds form, that was also rather puzzling to me. I didn't know how in the world these things did happen. Like I say, at the time, I didn't know it was science.
How did you find out it was science?
Well, it turns out that by some remarkable chance, I got hold of a science book. I couldn't read English at this time, but I could study the photographs and determine how a submarine worked. And then I realized there was other people that were asking similar questions, and there could be reasonable explanations. Otherwise, they couldn't make the submarines,
So
right?
the book was in Spanish?
No, it was in English. It turns out that my first language is Spanish. My parents are from Mexico, and we spoke Spanish at home.
Are there very many Mexican-American physicists?
No, there aren't many. I understand that I'm the first one, and I finished my work in 1961.
First ever?
First, yeah.
Why is that there's so few?
Well, I think there's many reasons for this. One of them is the fact that Mexican-American children do not see Mexican-American scientists. They don't have the role model. And I think if these opportunities were made known to them and some of these examples were set, I think we would do much better. What happens, frankly, is that a lot of times there are counselors and other teachers who feel that because the particular individual is not fluent in English, that for that reason he can't master science.
Right.
And as a result, they're advised to go into vocational schools and the like. And
It shouldn't really make any difference because science is science and the moon affects everybody in the world, no matter what language it is.
that's true, I agree with you.
Whenever there's trouble, we're there on the double. We're the Bloodhound Gang. If you got the crime, we've got the time. We're the Bloodhound Gang.
Did you see the morning paper? It looks like Mr. Bloodhound's really gonna nail that gang of truck hijackers.
Bloodhound Detective Agency. Whenever there's trouble, we're there on the double. Mr. Bloodhound isn't here. Yes, Mrs. Bloodhound. We'll be right there.
What happened?
Mr. Bloodhound is missing.
Mr. B is due to testify in court in a couple of hours. We've got to find him fast.
You think it's that mob of hijackers, the Sniffle Gang?
Of course. Why, he has enough evidence to send the whole pack off to prison. Obviously, they intend to keep him out of sight until after the trial.
Well, what exactly happened?
Mr. B picked out his favorite walking stick and went for his usual brisk walk early this morning. He never came back.
That was only a couple of hours ago.
Read this. It was slipped under my door just before I called you.
Bring Sniffle Gang tape cassette to downtown bus station. Leave in locker. Do not look back. Do not inform police. Signed, James Tress Bloodhound.
He has no middle name. And there are no tapes.
James Trez Bloodhound. Must mean something.
Sure crossed out a lot of words.
It's not like him to make so many mistakes.
Those don't look like mistakes. Maybe he's trying to send us a secret message.
Unless he was just nervous.
Mr. B? Oh, nerves of steel. They'll be lucky if he doesn't pull a Houdini and escape. That must be it, Vicky. He persuaded them he had a tape in order to write a secret message. Mr. B's been making a study of codes and ciphers. I just finished stitching this for him. He told me it means home sweet home.
In what code?
He didn't say, but it must be somewhere in his code books, over there.
We'll get busy on the letter.
And I'd better rush off and leave a phony tape at the bus station. A little Mozart. That'll keep those hoodlums occupied for a while.
How much time do we have to break the code?
Half an hour at most. Leave me a message and be careful.
No, that's not it. Wrong code.
There must be a zillion different codes. Que lío.
Mr. Bloodhound's phony middle name, Trez. What did he mean by that?
Means 3 in Spanish.
3.
There's 3 words at home sweet home. Maybe he used the same code in the letter.
We know E stands for H as in home.
E, F, G. Got it.
Secret is 3, all right.
The H in home is 3 letters forward in the code letter. The whole message is that way. I shifted the bottom alphabet 3 spaces to the left. Okay, let's start on the letter. If Mr. Bloodhound used the same code in his letter, we'll break it in no time. What's the first word?
DBJ.
Back, take it down. D is G. B is E. J is M.
Next word. J.
M.
L.
O.
Q.
P.
B.
E.
I.
L.
Next word. O.
R.
L.
O.
L.
O.
J.
M.
Last word is P.
S.
F.
I.
U.
X. Jim Motel, room 6.
Will the gang find Mr. Bloodhound in time? Watch tomorrow's thrilling conclusion of The Case of the Missing Bloodhound.
Today we've been talking about the sources of light in our lives. From the sun, that all life depends on, to the light bulbs that help us when the sun can't, to lasers that put light to work at all kinds of new jobs.
We now have lasers that have a power output of 1,000 trillion watts. This bulb that I brought you only puts out 100 watts.
Yeah, but it doesn't blow the system. And for all the new lights we're making, we still have to depend on the same old source, the sun, right?
Right. And it's a relatively small star as stars go.
Yeah, but it'll do. Look how far it shines.
One Contact is a production of the Children's Television Workshop.
Meyer and Frank and Keds join OPB to present Paul Horn and Portlander John Stowell at the Washington Park Zoo Wednesday night at 7. Admission is $5.
This is PBS.